Alright guys, welcome to this page of the notes. What we're going to do is now take all of that information we just learned about the properties of mid-segments, knowing that the mid-segment is parallel to the third side and that the mid-segment is half the length of the third side. So we're going to take those properties, we're going to use those properties to now do a couple of problems together. So let's go ahead, jump right into these and see what we've got. What I've done is I've gone ahead and given you a diagram right here, and what I'd like you to do for me is determine, right, that mid-segment is parallel to the third side. So I want you to show that this mid-segment, JK, is parallel to the side, GI. Are they actually parallel? Our property of mid-segments says that they should be. Let's find out if they are. And then also I want you to figure out if that mid-segment is half as long as the third side. Again, the property of mid-segment says the mid-segment should be half as long as the third side. We'll find out if that's true or not. So here we go. Let's just jump right into this. And we're going to start off by, let's do slopes first. So I want the slope of my mid-segment, which is JK. So let's find the slope of JK. Now remember, slope is rise over run. And fortunately, it's already been graphed for you on a coordinate plane. So let's go ahead and find the rise from J to K. And if I just take a quick look at it here, it looks like I'm going to have to go up, right, 2 units. Up 1, 2. That'll get me on the same horizontal line as K, which means that my rise is a positive 2 since I went up 2. Now, slope is rise over run. So now I need to figure out how far horizontally do I have to go to get to K. Again, it's on a coordinate plane, so you should be able to just count. 1, 2, 3, 4. I had to go 4 units in the positive direction horizontally, so my run is 4. Well, 2 over 4 will simply reduce to 1/2. What that tells me is that my mid-segment, JK, has a slope of 1/2. Now, if JK is a midpoint, it will have a slope that is equal to that of GI, right? Because parallel lines have the same slope. So let's find out. Let's go ahead and do GI. So we want the slope of GI. What we're hoping is that they're going to come out to be the same. Again, slope is rise over run. So let's do the rise first. So again, it's on a coordinate plane. I should be able to count 1, 2, 3, 4. So it looks like I had to go up positive 4 to get from G up to a horizontal line that'll run through I. And then it is rise over run. So let's count our run. 1, 2, 3, 4, 5, 6, 7. I get 8. And yep, just like that, right? 4 over 8 will reduce to 1/2. So here's what we find. We find that both JK and GI have the same slope. If their slopes are the same, what does that tell us? Yeah. It tells us that those lines are in fact parallel, which is exactly what we expected. If JK is a mid-segment, it has to be parallel. Okay, great. So that takes care of that part. We now know that those two lines are parallel. The next thing I wanted you to figure out is this. Is JK half the length of GI? Now, if I had, there are ways that I could make these problems easier. If JK and GI were perfectly horizontal or perfectly vertical, right, you would be able to just count their length. Since they're on a coordinate plane, figure out how many units it is from G to, or from J to K or G to I, right, and is 1/2 of the other. But since these lines are on a diagonal, you can't just count their length. So, in this case, it's slightly trickier where you're going to need to use the distance formula, which we actually saw previous in another section where we were trying to find the length of a line segment, and we needed to use the distance formula because it was on a diagonal. That's fine, no problem. In order to use the distance formula, you guys will remember that D is equal to, it is x2 minus x1 squared plus y2 minus y1 squared, and you'll take the square root of all of that. So that is our distance formula. You should remember that from all the way back in chapter 1. We did that at the very beginning of the year. In fact, chapter 1, section 1, it was right in the very first section. First thing, the midpoint formula, the distance formula, and the line addition, the segment addition postulate were all things we looked at all the way back at the very, very beginning. So anyway, here we go. In order to use the distance formula, I need ordered pairs, right? That's what my x1, y1, x2, y2 are. They are my ordered pairs. So let's go ahead and get those. J is going to be at a -6, +2. J is at -6, +2. K is at -2, +4. Again, I know that because it's on a coordinate plane, so all I have to do is just find those ordered pairs. G and I. G is at -7, -1, and I is at, it looks like a +1, +3. Alright, so now that I've got my ordered pairs, again, all I have to do is just assign x1, y1, x2, y2, which really isn't too terribly tricky. We'll do x1, y1, x2, y2, and again, for G and I, x1, y1, x2, y2. Now that I've done that, guys, it's plug and chug into the distance formula. Just make sure you put everything in the correct spot, right? We're going to do it twice. Once for JK, once for GI, right? We're going to find the length of this segment, find the length of this segment, and then compare the two. So as long as you put everything in where it's supposed to go and then don't fat finger something on your calculator, you really shouldn't run into any trouble here. So here we go. Let's do JK. So JK is going to be equal to, okay, it's going to be a -2 minus a -6, which we will square, plus it's going to be a 4 minus a 2, which we will square and take the square root of. GI, let's see, where can I squeeze GI in it? I might be able to squeeze it in right here. Let's see. Okay, so GI then is going to be that segment GI, right, because we got to do it twice. I got to find the length of JK and the length of GI. Here we go. So x2 is going to be 1 minus, so 1 minus a -7, which we'll square, plus, sorry, I need to erase that so I'm not running over it. Let's see, my y2 is a 3. Minus a y1 is, right, a -1. And we'll square that. And then, of course, take the square root of all of it. All right, here we go. So now I've plugged everything in. Should be just a little bit of real simple math here. Here we go. JK is equal to, first this one, add the opposite, I wind up with a +4, and a +4 squared is going to be 16. 4 minus 2, well, 4 minus 2 is going to be a 2, 2 squared is a 4, and so I wind up with 16 plus 4, I'll take the square root of all of that, which means JK comes out to be the square root of 20. Now, the square root of 20 is not a perfect square, and generally I would leave this as a radical, right? Leave it as a square root if it's not a perfect square. However, remember, I'm going to compare this length to the length I get for GI. So in this case, I would go ahead and approximate that as a decimal. It'll make it a little bit easier for us to do. And if you do the square root of 20 in your calculator, you get 4.47. All right, let's do GI. Here we go. Add the opposite, that's going to be 8 squared is 64, so we wind up with 64. Add the opposite, that's going to be a 4 squared, which would be 16. So plus 16, we wind up taking the square root of all of that. 64 plus 16 is going to give me the square root of 80. Now, once again, square root of 80, 80 is not a perfect square. Yes, absolutely, we could simplify. But remember, I'm going to compare these two lengths. So just go ahead and convert it to a decimal. It'll make it a little bit easier to work with for you. So there we go. Now the question, right? Remember the question we're trying to answer is we know that a midsegment, the property says the midsegment is half the length of the third side. Well, here's my third side, 8.94. The question is 4.47 half of 8.94? And the answer is yes. Yes, it is. Take 8.94, divide it by 2, and you get 4.47. So what we know is yes, JK is 1/2 GI. Turns out that property holds out to be true. So they are parallel, and yes, JK is half of GI. All right, I got another one for you just like this one right down here. Except this time, I didn't give you the triangle on the graph, I just gave you a coordinate plane and I gave you coordinates, which means we're also going to then need to find the midsegment before I can actually answer all these questions. Are they parallel? Is the midsegment 1/2 the third side? So now, here we go, let's just jump right into this. L is at 2, 7, 2, 1, 2, 3, 4, 5, 6, 7. There's L. Let's see, M is going to be at 10, 9, 10, 9, that's right there, that's going to be M. And N is going to be at 8, 1, 8, 1, that's N. And we'll go ahead and I'll do the best I can here to connect those guys with a line. Good. That's not bad. Not bad for freehanding it. Not bad for freehanding it. I'll take it. Okay, great. So there's my triangle, LMN. Triangle LMN. Now, what I need to do, right, is I need to find P, which is the midpoint of LM, and Q, which is the midpoint of MN. So we need to find those. Now, you certainly could, absolutely could use the midpoint formula. You know the coordinates of L and M. Plug those into the midpoint formula, and the midpoint formula will give you the midpoint. However, since it's on a coordinate plane, we could just count, right? I know the line is a diagonal, but check this out. The slope is, the slope of LM is 2, a rise of 2, right? And a run of 8. So LM is 2 over 8, which will reduce to 1/4. So here's what I can do. I can find the center of line LM by going up 1, and over 4. Up 1, 1, 2, 3, 4, right there is going to be the midpoint, which we'll call point P, right? That's exactly halfway. Up 1 over 4, up 1 over 4 gets you the rest of the way, right? So just a quick little shortcut. Absolutely midpoint formula would work. Please feel free to use so you'll get the exact same point. Turns out we can do the exact same thing for MN, the slope of MN, right? Rise over run. 1, 2, 3, 4, 5, 6, 7, 8. That's a rise of 8. A run of 2, which is going to reduce to what? Well, 4, right? So the slope is 4. That's up 4 and to the right 1. We can do the exact same thing. Count up 4, count over 1. 1, 2, 3, 4 over 1. Right there is going to be the middle, again, because it's another 1, 2, 3, 4 over 1 to finish it off. So that puts point Q right there at the midpoint. You could use the midpoint formula or this neat little shortcut here where you just find the slope and then do the slope one time to get yourself to the middle. Anyway, this is my mid-segment, PQ. Now, just like we did above, we want to know, are the slopes of PQ and LN the same, right? They're supposed to be parallel lines. Well, let's find out. The slope of PQ is equal to, again, it's rise over run. So from P to Q, I'm actually going down 1, 2, 3 units. So that's going to be a -3 and a run of 1, 2, 3, run of 3, which means I have a slope of -1. Let's find out. Slope of LN. Same thing, rise over run. So down 1, 2, 3, 4, 5, 6. Down 6. So that's going to be a -6 because I had to go in the negative direction. My run is going to be 1, 2, 3, 4, 5. +6. Oh, and sure enough, those are the same. Okay, so far we know that those two lines are parallel because they both come out to have the exact same slope. Now all we have to do is figure out, is PQ exactly half the length of LN? Again, there's no shortcuts here. The lines are diagonal. You're just going to have to do the distance formula. That's fine. We can do the distance formula. A little bit of plug and chug in here. So let's see. L. I need L. L is at 2, 7. N is at 8, 1. I need P and Q. P is at, what is that? 6, 8. And Q is at 9, 9, 5. All right, so those are going to be my ordered pairs. Again, x1, y1, x2, y2. In fact, let me go ahead and do that now. X1, y1, x2, y2, x1, y1, x2, y2, which means we're just going to simply plug and chug into the distance formula. X2 minus x1 squared plus y2 minus y1 squared. Make sure you put everything in the right spot. Don't fat finger something on your calculator, and you shouldn't have any issues. So here we go. LN. Let's see what we get. We're going to have 8 minus 2, which we will square, plus 1 minus 7, which we will square, take the square root. PQ, we're going to get, let's see here, it's going to be 9 minus 6, which will square, plus 5 minus 8, which will square, and take the square root of. Okay, LN. I think you guys can probably do a lot of this in your head. 8 minus 2, of course, is a 6. 6 squared, 36. Okay, so I got a 36. Let's keep going. 1 minus 6, or I'm sorry,